Hey, you're back with Mr. C watching 3-9 Scientific Notation. I really like this lesson, and it is one of the quicker lessons to learn, so I'm happy for you to tune into this right now. Once you're done writing this screen, moving on in 3, 2, 1. Please check your homework, the problems that were assigned. Moving on in 3, 2, 1. So we do have vocab notes today. Remember that it is useful to underline the word that we're having the definition of, and remember it is useful to use lines in your notes to separate for better organization. Once you're done writing this section, we're ready to go on in 3, 2, 1. We just talked about what scientific notation was. You took notes on it, so now you're going to have some experience working with it. Remember, you are listening for a clue word during this section. So I have two questions going into this lesson, if I were you, and it'd be, what is scientific notation, since that's what it's about? Not sure if I know what that is. And why is it useful to me or others? I know you took a definition of what scientific notation was on the previous slide, but now we're trying to understand that. So let's read up here. How can you write very large numbers using scientific notation? I think I'm already answering why is this useful? It's specifically useful for very large numbers. So a number written in scientific notation is expressed as a number greater than or equal to 1 but less than 10 multiplied by a power of 10. So let's put an example to that. So if we look up at the top here, we have 3 examples of what scientific notation might be. Well, look at this one. 12 times 10 to the 4th power. I know what 10 to the 4th power means, but is this scientific notation? Well, it needs to be a number that's equal to 1 but less than, equal to or greater than 1 but less than 10. That's not less than 10, so this is not actually how scientific notation would be written for this problem. It would actually be written as this. Right here, this is how it would look. We'd move the decimal 1 over, and we'd add 1 to the 10, so it'd be 10 to the 5th power. And these work because this number is between 1 and 10. I'm noticing a similarity that there's always, it's times 10 to the something power is something to do with scientific notation. And let's go to the example. How can you write the temperature of the sun's core in scientific notation? Man, that's hot. That's a little bit hotter than my oven gets. And in fact, I believe if you cook bacon at this temperature, it actually starts to say, "Ow, that hurts," because that's very hot. In fact, you can put anything in the center of the core and it starts talking like that. It's quite crazy. But let's go on. So step 1, taking that number that we just got from the sun's core, 27 million degrees Fahrenheit, which is quite warm. So how am I going to take that number and make it into scientific notation? Well, it says for large numbers, for big numbers, move the decimal point to the left to make a number that is greater than or equal to 1 but less than 10. So just between 1 and 10. All right, so we're moving the decimal point from over here all the way, and I see that 2.7 is a number between 1 and 10. So that will work for us. And what I see is a lot of words here, and so I'm going to make it simpler. I want you to read this right now, and then I'm going to explain it in 3 seconds. Please pause the video. 3, 2, 1. All right, so the first question I had is, how did they get 2.7? Well, we needed a number. We're going to look at this number. We're going to try to get a number between 1 and 10, and I know that 2.7 there is between 1 and 10. And then how did they get 10 to the 7th power? Well, you're going to count here. I know the decimal is here on a whole number. They don't write it because there's no reason to, but it is there. And so how many times did we move the decimal to get it way over here between a number and 1 and 10? So we move 1, 2, 3, 4, 5, 6, 7. Okay, so that is 10 to the 7th power. So in other words, if you took 2.7 and you multiplied it by a secret word as wonder, and you multiplied it by this number right here, then you would get 27 million. So 2.7 times 10 million, that's 27 million. Well, how did Mr. C know that 10 to the 7th power is this number right here? Well, you can count the zeros. I see 1, 2, 3, 4, 5, 6, 7. 10 to the 7th power is a number with 7 zeros. So I just had the 1, and then I wrote 7 zeros, and I know that 10 to the 7th power is 10 million because I added all those zeros. And I know it's 10 to the 7th because I counted backwards. 10 to the 7th power could also mean this right here. It could mean 10 times 10 and just 7 times. And if you did multiply that out on a calculator or by hand, you would get the same answer as a number with 7 zeros. So I just think of this is how many zeros that number has, and that's how many decimal places we went back. Let's go on to example 1. So here's example 1. So we have example 1, and you have lines around this, and so you can write this number. We're going to try to make that into scientific notation. What's the first step? Oh, well, the first step is I'm going to try to make somehow this number between a number between 1 and 10. So this is different than the first example. This is how can you write very small numbers using scientific notation. The first example was very large numbers. How can you do it with very small? And there is a difference, and I hope you're paying close enough attention to see the difference. So following it right here, I'm going to see again what number between 1 and 10 can I make this into. We stopped the decimal right here, which makes a number 5 and 600ths. 5 and 600ths is between 1 and 10, therefore we're going to use that. But next, I kind of want to find out how many times did I move the decimal. So then I would count. 1, 2, 3, 4, 5 times. So I'm going to predict that it's going to be something close to this. I know I moved it 5 times, but is that going to be the answer? 5 and 600ths times 10 to the 5th power. So let's zoom in here to see the answer of what they got. They said that it's 5 and 600ths times 10 to the negative 5th power. That's very interesting. All right, so follow my thinking here. 5.06 times 10 to the 5th power, the regular 5, you'd be moving the decimal back over to the right when you multiply that by the power of 5. So I would count 1, 2, 3, 4, 5, and it moved over 5 times. And so the answer there would be 506,000. But I'm looking right here, and that's not the number that we're trying to put into scientific notation. But we see when it's 5 and 600ths times 10 to the negative 5th, I think of negative as going backwards. So we start at 5 and 600ths right here, and we go 1, 2, 3, 4, 5, because it's to the negative 5th power. That's how many places we move to the left. And then we end up with this number right here. Negative means backwards, and that's what we did here. I would like you to have everything on this screen written. We're going to move on in 3, 2, 1. Here's example 2. Try to do this by yourself. And I'll show you the answers in 3, 2, 1. So for the first one, I found where the decimal would be for 3.5. I went right here in the number, because this is the number between 1 and 10. And I did 1, 2, 3, 4, 5, 6, 7, 8 numbers back. So I did 10 to the 8th power. This one I found out where the decimal would go right here between 6 and 4 to make 6.4. If I moved it to 64.88, that would not be a number between 1 and 10. So we go 1, 2, 3 numbers back, 10 to the negative 3rd, because remember it's backwards. Now if you got these two right, I do applaud you. I'm now going to tell you how to do them. So you would have needed to look at 657. Where can I put the decimal to make it between 1 and 10? I can put it right there. I got my base number. How many times? 1, 2. That's how I got my 2 right here. How can I make this number between 1 and 10? Put the decimal between the 4 and the 9. How many times back is it? 1, 2, 3. Negative 3. Please do page 83, numbers 10 through 17 for independent or partners practice. The answers are coming in 3, 2, 1. Please check your answers. After you're done with this, please go to the gas station on Socrative, and then choose whether you'd like to work in pairs or by yourself. The group game answers are coming in 3, 2, 1. Thank you so much for watching this video, and if you don't know, you are awesome.